All right, so our next speaker is longtime Node core contributor, TSC member, Michael Dawson. We'll be talking about native add-ons for Node. And yeah.
Well, thanks for the introduction. And thank you, everybody, for coming to listen to me to talk about building Node add-ons like it's 2023. A little bit about myself before I get started. I'm Michael Dawson. I'm the Node.js lead for Red Hat and IBM. That means I get to spend a lot of time in the Node community. I'm on the technical steering committee, as well as active in many of the working groups, one of which is the one which works on node-addon-api. Also involved in the OpenJS Foundation, as well as getting to work with a lot of great teams within Red Hat and IBM who are either like building Node.js applications, deploying them at scale, or helping our customers do that. If you want to follow me on Twitter or GitHub, there are my locations as well. So, just before I get started, I wanted to tell you a little bit about what I'm going to take you through, the journey I'm going to take you through. So first of all, what are native add-ons and why do we need them? Brian helped me out a little bit with that yesterday because in talking about FFI, he talked about some of the earlier ways to interact with native code, but I'll give a quick refresher of that. I'll also talk about about alternatives, FFI being one of those, but there are some others. I'll then look specifically at building C and C++ add-ons through Node.js's history. And then I'm going to recap as to why I think node-addon and node-addon-api are so great. I'm then going to go into some of the really interesting things that node-addon-api has enabled, and that's running with different runtimes, as well as being able to build your add-ons in different languages as well. And finally, I'll finish up with some resources if you want to get started. And then if I've really got you inspired and you want to get involved in the Node API work, I'll give you an introduction to the team that's currently working on that. So what are native add-ons? I'm kind of coming around to the thought that what you're doing when you're writing native add-ons is you're writing JavaScript. You're writing like JavaScript objects, functions, and so forth. You're just not writing them in JavaScript. You create objects and functions that you can call from your JavaScript code, but when you actually call them, the code that runs is in some other language. And so that's why I look at native add-ons as writing JavaScript just in a different language. So why would we want to do that? And as Brian mentioned, there's a lot of code out there, and sometimes it's just best to reuse that existing code versus having to re-implement it in JavaScript. So there's lots of components we just want to wrap up and use them. Another good reason is speed. There's some things that will just always run faster in a compiled language versus JavaScript, even with all the great advancements we have in the V8 JavaScript engine. And then finally, there's just some things you can't do in JavaScript because Node or the JavaScript engine hasn't exposed those. So for example, if I want to access my serial port, there may be no way to interact with that serial port except dropping down to some native code. And so that's one of the cases why we want to use add-ons. So that's some of the reasons why you want to use native add-ons, or at least reasons why you want to interact with native code. So what about some of the alternatives? As we saw yesterday, Brian was talking to us about FFI, and it's like, hey, doesn't that look easier in terms of just calling an existing shared library without having to write any code at all? And it does, it is a good match for some use cases, and because of that, there's been some libraries. Brian mentioned node-FFI, NAPI, as well as the PR he has for adding foreign function interface support to Node.js itself. And in fact, way back when, in 2016, when we had a collaborator summit and we actually started working on Node API, we already discussed FFI, WASM, and some of the alternatives, and we really came to the conclusion that it's a yes-and type situation where all of these alternatives make sense for different use cases, and therefore, we want to move forward on them all. Another alternative that you may hear talk of quite often these days is WASM. That's WebAssembly, and with WASI, which gives you a system interface, you can interact with the outside world. And that's another way where you can take native code, compile it into something that we can now run with V8 and interact with our JavaScript. But because it's sort of a yes-and solution, it's because the different alternatives are either a better fit or worse fit for particular use cases, and you can't necessarily do everything with every one of the solutions. So really, FFI lets us call existing C code from JavaScript, but it doesn't really let us write our code, like write JavaScript in some other language, which is sometimes what we want. Whereas, in the add-ons, we can make calls to JavaScript and then also from the code that we've called back into JavaScript. WASM does allow that two-way communications, but the interface is actually much more constrained today. And also, due to its sandboxing, it also often constrains what you could get at in the operating system. So if you wanted to get out to something, well, the WASM sandbox model may not let you get at it anyway. So let's go back all the way to 2014. This was about 5 years after Node.js came out. And right from the beginning, people had wanted to write native add-ons and interact with native code for the reasons I touched on. And we're having challenges. Changes in the V8 APIs made that a difficult situation with lots of churn, having to update your code. And so in 2014, we had NAN 1.0, which is about 5 years after Node came out. And this was the first pass at making it easier to build your native add-ons and to reduce the churn that you'd get from newer V8 versions. Now, if we look at the code that a native add-on has for a simple hello world, if we're using NAN, we can see there's some functions in there that are prefixed by NAN, and they wrap up the things which were most often changing. And the idea was to provide some isolation so that when they changed in V8, we could change the implementation and that the native add-ons themselves wouldn't have to make change. And that actually provided a lot of value. However, if we look at the types that are used, those types are still very closely tied to V8. And so if any of those types changed, or any, there's still possibility for change in V8 which would leak through, and you'd have to rewrite your applications. It's even, it was to the point where in Node, we actually implement a check that says, if you're running with a different version of Node than you compiled your Node add-on with, we're not going to let you run at all, because we just think that's not going to end up being a good situation, and it's not going to work for you. It's called node module version in this case, but we tend to bump that every single time we do a major. So effectively means every time there's a new version of Node, you're going to have to recompile your native add-ons. Otherwise, they're not going to work. In this case, you can see I have compiled and installed my add-on with a particular version of Node. I then will run a script to set a different version of Node, and I get this error saying, oh, wait a sec, you're going to have to recompile your native add-ons. So let's move forward to 2018. And actually, this work started earlier. It was closer to 2016. We got together in a collaborator summit, a Node.js collaborator summit, and we were talking about what are some of the biggest challenges that still face Node developers. And it was discussed that creating native add-ons and maintaining them was still one of those main pain points. So at that point, we agreed that we should start working on an ABI stable API called node-api, which culminated in 2018 with it becoming stable in Node 8.12. And it's important to mention that the target was always to be that we would only hit 80% of the use cases. We wanted to decouple ourselves from V8 and provide full isolation, but that also means that we're not going to be able to expose everything, and therefore we're not going to cover all of the use cases that are available. So in that sense, we felt that we're going to provide a set of APIs. We'll let 80% of the people write the native add-ons that they want, and actually that's going to add a lot of value because it covers the largest portion of the users out there. So now let's look at building a native add-on in C or C++ with Node-api. And in this case, if you look at the code, you can see that there's functions like nappy create string UTF-8, nappy define properties, and these are all part of the Node-api definition, as well as all of the types, and really is completely independent from the JavaScript engine that we're actually running underneath. We can see down below, I still have the exact same JavaScript code which runs the native add-on, and that's sort of preserved over all the different methods. So this is what you could then do. The nice thing is that it's now ABI stable. So when I take my same example that I had before, I install and compile my native add-on with a particular version of Node.js, and that's what I'm doing the first line. So it's set to v16. I run node hello.js. I then run my script, which is going to switch the version of Node to Node 18. I run it again, and hooray, it actually runs. So instead of getting that big error that says, whoa, you compiled your native add-on with an earlier version, it just works as expected. And that's really important, especially for people who want to manage native add-ons and make it easier for users to consume those. Node has a nice built-in mechanism, so when you do your npm install and there's native add-ons, it will compile them and build the native add-on. But that actually adds a lot of requirements. You have to have the compilers installed, you have to have Python installed. So some module owners want to avoid that, and so they pre-compile binaries. And when you do the npm install, it just pulls down the binary for your particular platform. Well, before Node.api, you would have to maintain one for every different version of Node.js, which is a big headache. So with Node.api, you can now build one version of your add-on, and it's going to run with any different version of Node.js, which is a really great thing, and one of the main benefits that you get out of this. Now, if you looked at the previous page, you might say, yeah, but there's a lot of more lines of code there than I saw when I was using nan. What's going on? I don't think we don't necessarily have all of the error checking in even, and there's a lot of lines of code there. So that's not so great. We specifically chose to make Node.api a C interface because C++ has a lot of nuances with its name mangling and all those things. And we didn't feel that we could ensure the ABI stability, so we stuck with C. And that's where you get the more verbose code that you have to write if you're using Node.api directly. But we also acknowledge that we want to be more efficient, we want fewer lines of code, we want things to be more readable, and we can often get that through C++. So node-addon-api is an npm module, and what it includes is basically a bunch of macros and C++ templates that will let you write your add-ons in C++ and use an API which is more concise and more familiar. And as you can see in this example, uses a lot fewer lines of code. But actually, all those templates and everything just boil down to exactly the same code that you would get with writing it directly in C. So it's really just some nice sugar on top of still the C-based API. But it does let you write your add-ons in a way that look, I think, a little bit more readable in here, in your method. You're creating your method. You can very easily see that I'm returning a string, and I can see that I'm setting, a key and a value in terms of my exports object, and it's starting to look a lot like I'm writing JavaScript in C or C++. So that was one of the things that the team worked on after the initial version of Node.api. And we believe that a large number of people use node-addon-api. Now, again, the code to actually call your native add-on always stays the same. So I'm going to recap a little bit now and go back to, well, why do we think Node.api is so great? So one, there's no code changes needed for new Node.js versions. In the past, you might have actually, and especially if you coded directly against V8, you might actually have to change the code in your add-on for it to work with a version of Node.js. Even if you didn't have to change your code, if you had precompiled binaries, you would have had to generate new versions of those and then publish those new versions of the precompiled binaries. Or users would have to know that they had to recompile their, reinstall, do an npm that install that reinstalled and rebuilt all their native add-ons if they were moving up to a new version of Node.js. So you don't have to do that anymore. You can build once and run with later versions of Node.js. The other thing I think that's really great about Node.api is that we really try to stick with the principles in ECMAScript 262. We have actually a well-defined set of criteria for things that will be added, and that includes looking at it to make sure that we're not sort of introducing a concept that's not going to fit into something that's 262 compliant. Because from the very beginning, we wanted to make sure that we were always cross-runtime compatible. At one point, there was actually an effort to make Node support multiple backend JavaScript engines, both V8 and Chakra Core. And although the Chakra Core implementation really never came to be, that initial focus really helped us make sure that, as we see and we hear people talk about different runtimes, and we've had a few talks today, just a couple talks before about how there's more than just Node.js out there. It's great now that that Node.api itself is really not tied to any one runtime, and so you can get cross-runtime compatibility. The other thing that the implementation has allowed is cross-language support, and I'll show you a little bit later that you can now write add-ons in languages other than C and C++, which I think is a really great thing. And it's also nice in that we've been working on separating Node add-on or Node API from Node.js itself, so that if you want to build add-ons, you don't necessarily have to install Node and use it. So looking at cross-runtime compatibility, we've got a list now on the ABI stable Node repo that shows the bindings for Node API and other runtimes that support them. So most of the other runtimes that you've heard mentioned, so Bun, Dino, things like Electron, EMNAPI, IoT.js, and Veil, they've all done some level of compatibility with Node API. And so that's so that you can write your add-ons and have them run with the other runtimes as well. Also shows that shows that, even though you think, why would I have native code in most of my applications? I think there was one survey done at a point where it turned out that almost like 30% of applications would end up with some bit of native code in them. And the fact that other runtimes have said, well, actually, we've got to have a solution for these native add-ons, and we want to reuse the ones that are actually in the ecosystem already through supporting node-addon-api supports that fact that they're used widely enough that it really does matter. So in terms of making it easier to build your native add-ons using Node API without having to have Node.js itself, we've created a new repo under the Node organization, which is Node API headers. We periodically sync those headers into that repository. Node API itself doesn't change all that often, so that's not a big effort. And so that you can use that repository to pull in the headers and compile your add-ons without having to install Node itself. The other thing we'd really like to do, we just haven't gotten there. It's always like with all the different efforts that we're talking about, like Brian talking about FFI, we just need somebody who has the cycles to make it happen. We'd like to pull out the tests. We have a really nice set of tests in the Node.js test suite, but the only way to easily run them today is to run them as part of your Node.js builds. We'd like to pull that test suite out and put it into its own repo. So again, if you're building your own implementation, you could run those tests to validate that you have a proper implementation. We just haven't gotten there yet. It's really just an empty repository. The other thing I mentioned was cross-language support. It's nice to see that people have now started to write add-ons in other languages because of the architecture and the approach that we took. For Rust, it's actually, there's quite a few different alternatives. There's 4 different alternatives out there. For some other languages, it's fairly early stage. They range from, fairly implemented to just, an experiment that somebody's working with. But they cover a good number of languages like C#, Swift, Nim, Zig, and Go. And I'm sure, other ones can be built as well. It's really down to that very well-defined C interface and a simple method of loading the entry points that we have in node-addon-api. So now I'm going to jump into some examples of actually running with different runtimes and with different languages. So I said, hey, let's build an add-on using Rust. And I chose Neon because it was the one that, when I looked at it, at least at the surface level, seemed to fit in my mental model of writing JavaScript in some other language the best. So this is an example. It uses the exact same JavaScript in terms of calling the hello world. Again, I think you can look at that and fairly easily see that, like, hey, I've created a function called hello. That function returns a string, which is called world. And that in the main function, I'm basically setting my exports, and there's a function in those exports to say hello that I can call with that function. It looks very much like building your application with node-addon-api, except we're doing it in Rust. I just wanted to show this. So in terms of actually being able to do that, I used the standard project to create my project, to make my add-on. The only things I did have to change is I wanted to use bindings, because if I showed you that I wanted to keep the same JavaScript side throughout all the different examples, so I needed to add bindings to my dependencies. The other thing I needed to do was change the build script, because with bindings, it ended up that it was looking for the built add-on in a different location. And so, with those 2 tweaks to the package.json, the application the add-on built and ran as expected. I did want to show a little bit longer example. I'm talking about writing JavaScript in another language like Rust. And so I just wanted to show another example where I'm basically creating an object, setting members on that object, and so forth, and just a little bit of a bigger example to sort of flesh out that concept. So we looked at building add-ons in a different language. Let's look at running our add-ons with a different runtime. I just chose Bun as one of these. I wanted to try one of them out. And the first challenge I ran into is that, at least at the time, the Bun install didn't do and run the scripts that you needed to build your native add-on. So I fell back, and I built my native add-on with npm install, and it ended up with an add-on that was ready to run. I did run into a few other challenges as well, so it didn't just run out of the box. I had to update it to not use the bindings package. I'm not quite sure that might not be a fundamental issue. I just didn't spend enough time to figure that out. So I just removed the dependency on bindings, and the add-on having been built, I just did a direct required to load that in. But at that point, the great thing is I ended up with an add-on that I could basically run node hello world, and it ran great. Then I just ran the exact same thing with Bun, and it runs again. So now I have an add-on that not only runs with multiple versions of Node, but it runs with other runtimes as well. Now, there might be some caveats. I know that it's been mentioned some of the other runtimes haven't fully built in all the compatibility with Node.js, and I expect that the add-on API may be one of those places as well. But like at the starting point, they seem to build and run the same, which is really great. So let's move forward to 2023, because that's what year it is now. Where are we? We're at the point where we have an ABI-stable API. We don't need any code changes for new versions of Node.js. We can achieve that build once for many versions of Node.js, which I mentioned is really important for people who build pre-built binaries. I showed that you can write in different languages and that we can run with different runtimes. Now, I mentioned earlier when we were starting to think about Node API way back in 2016, we targeted the 80% use case. And based on downloads, at least, I think I can say we've hit 43% so far. It was actually, I've got the 38%. That was like 2 or 3 months ago when I updated the talk for this round. It had already gone up 5%. So we can see, I think from the trajectory that, Node API is on a pretty good trajectory. We may never hit 80% because people don't necessarily update all of their old add-on modules, but I think being at 43% is a pretty good progress on that path. We always knew, 2016, that's quite a long path, but we always knew it was going to be a long path to getting people to use a new technique to build their add-on modules. And we see that in all sorts of different things. ESM, it's taking quite a long time. We can't expect people to change overnight because change costs them time, money. But I think this is a good example of if you build the right thing, over time, you will get people moving in the right direction. So before I finish, I just want to leave you with a few resources. Hopefully, I've inspired you that writing add-ons is interesting. Hey, maybe I want to get involved in helping out. The Node API doc has some great information. It documents all the methods, all the C-based methods that you can use, and has some great examples. The node-addon-api docs gives you all the information about the C++ interface. So that's a great way to get started as well. And there's also in the Node repo, Node add-on examples repo, and it's really useful because it has all the common things that you need to do, like creating objects, creating functions, doing callbacks, all those things. And often it actually has examples of how to do that with NAN and with Node API. Some of the newer ones may only be for Node API, but there's a good set of examples for, hey, I need to do something. Often just go there and you'll find what you need. And the Node API resource sort of presents that in a nice way as well. We have that page with the engine bindings where we like to track all the different runtimes and languages that you can use with Node API. And so really a good set of resources that you can get started with. The other thing I'd really like to point out is this is an example where we have a team/working group working on Node API. And I think this has been a really good experience for me. We meet once a week. I look forward to talking to the other team members every week. We go through issues, concepts, longer-term things that we need to work on in Node API. We have, as you can see there, we have over 103 contributors across Node API and node-addon-api. And so we've had a lot of collaborators, but this is a great place to actually come in and meet the people who are actively working on it today. And so if you want to sort of get involved and find some people who might help mentor you, find some things that need to get done, just coming in here and getting to know the people who are there every week and have some really good discussions. The meetings are open. They're on the Node.js calendar, so you can always find them there. And it's an open meeting where you're free to just join and listen if you want, or if you want, you can always talk, because I find that everybody who joins the meeting brings a different perspective, and that really adds value to what we're doing and how we move forward. So thank you very much. I think I'm just a little over time, and thank you very much for learning how to build native add-ons in 2023.
And thank you, Michael, for all the things. So I think we have a little bit of time, but we are going to use the time for something else. But that's a good question. Is anybody has some questions while we are waiting? A question over here. And yay.
Hi, are we still calling it an API now, or are we trying to call it Node API?
It's called Node API, so maybe I haven't updated the calendar.
Okay.
But yeah, I can update that.
It's Node API.
Yeah.
So, Amal.
So hi, full disclosure, the first time I heard about Node API, it was just from reading the docs many years ago, and I totally called it Nappy. I just wanted you all to know that, and I want to petition for it being called Nappy, so Team Nappy for the win.
Any other questions? Okay.
And I thought we were doing the
First of all,
raffle now.
Thank you, Michael. Everybody
Thank you, Michael, for coming.